All right, so now that we're all fueled up and sugared up and ready to go, let's talk about Objective-C syntax. So I'm going to start backwards. We're going to start at ground zero, and I showed you, what I try to do is overview everything I'm going to show you right now. So if you got overwhelmed this morning, don't worry about it. Now's when the pieces start making more sense. And we're going to go a little bit slower, build project from scratch. And I'm going to build it without iOS so you can kind of conceptualize the command prompt. But before I do that, I want to actually give you, and this is lecture number 1, by the way, I want to give you the syntax. So we have something called ID. ID is a data type, and it's used to define a pointer or an object. We don't have this, we do have an asterisk symbol that we use in C++. We also use it in Objective-C. However, we also have this other thing called ID. So it's sort of like the pointer, but it's an object in itself. So any type of object, as long as it is an object, we can use the ID data type associated with it. So what does that mean? So for example, you can define an object by going ID space an object. So it makes no sense to look at slides. So instead, we're going to write the syntax while we're looking at the slides. So if you have a computer, you have Xcode installed, hopefully by now you do. Let's go ahead and open up Xcode. We're going to start a brand new project. If you notice on the side now, because I worked with 2 of them this morning, you can see that I see them up here. If you don't like that, because I'm going to throw these away, actually if I don't like that, what I do is I go over here to File, over here to File, yes, and where it says Open Recent, I can go to Clear Menu. If I clear the menu, it clears these recently opened files. So if I come over here, click on Xcode and bring it back up, now it's empty. So if you don't want to have all that sample stuff showing there, you can get rid of it kind of easily. I'm sort of a minimalist. I don't want to look at all that stuff in there. So let's build a regular old Objective-C program. So I'm going to go create a new project. I'm going to click on the OS X application and do the command line tool. Click on command line tool, press next. And I'm going to call this one, oh, I don't know, I'll just go here starter. I'll call it starter. You can call it anything you want to call it. Make sure you select foundation as the project type. Fill in the rest however you want it. It doesn't really matter what you put in there. Go ahead and press on next. In this screen, you're just defining where you're going to put it. I like to put it on the desktop because then I just drag it and throw them away at the end of the day. You might want to keep it. If you want to keep it, maybe find a more permanent home for it. Doesn't matter where you put it. You can always drag the project and open it up from anywhere. It's not stuck in one location like it is in Android. So it's flexible. Go ahead and press on Create. We did this last time. We got it already. Talked about main. Main is kind of the starting point. Talked about a bunch of things are associated with main. Now what I'm going to do is kind of show you a few things about it. Actually, I'm going to run a little sample test here, actually. I'm going to get rid of that. I'm going to run it, and I'm going to see what happens. It says it was built successfully. And then if I look at the bottom piece, I see that the program ended with exit 0, exit code 0, and I see that it actually worked without the auto stuff. So I'm going to pull the auto. I pulled that auto thing out of there. Technically, I don't even need it anymore. I don't need it at all, actually. So I can still use Nslog and everything else. In fact, I could have left that Nslog in there. Here, I'll put it back just so you see that things work. Hello, world. You missed it. I covered the entire language. I'm just kidding. You're like, oh, really? Yeah, we're all done. And that's what's on the final exam. All right, for those people who just came in late, we did not just cover what was on the final exam. All right. What I did is if you just walked in, I just created a brand new project. So what I'm going to do now, we're going to talk about syntax. I'm going to talk about creating new object. I'm going to create some new objects. We'll talk about syntax, and we'll see how things work. What I'm looking at is kind of like a C program. I've got main. I even took out the auto stuff, so you don't need that in there. So let's talk about variables. We have all the primitives that you might find in any other language, like integer I. And we got float f. We got, these are the data types. This is the name of the variable that I'm creating of the data type. Now I have this new one that just belongs to Objective-C. I'm going to call this one ID my object. ID is a data type. It is a generic data type. This warning message is going to tell me that I've created it, but I haven't used it. Yes, unused variable. Yes, of course, I haven't used it yet. So we create IDs just like we create anything else. And what we're doing here is we're just creating a generic object. And to give you the textbook definition of it, which is right here, it's used as an object pointer, but there's no type. It can be of any type. It means it can be a string. It can be of anything. So any type of object, as long as it's an object, can be used with the ID type. So now you're going and thinking about, well, what is an object? We have objects, and then we have non-objects. So in Objective-C, we have both. These are not objects. So this is a non-object. This one is an object. This one's not an object either. This is a non-object. So what about an NS string? And I'm going to talk about NS for a second here. String with an asterisk, my string. That one's an object, except for I put a little space in there. I don't want the space in there. That guy's an object. So we have a NS integer, NS integer, NS, whoops, let's make sure we get this error here, equals, let's see, we have an NS integer, an NS string. Those are object versions of built-in data types. What's the NS? NS stands for next step. It's the object type that comes from the hierarchy of foundation that was from Coca. Maybe tomorrow I'll bore you with a little history lesson. Today I just want to get into the syntax. Tomorrow you'll figure out, but NS stands for next step. What is it? Nothing. You can take it off. All the objects start with a capital letter. All the non-objects start with a lower character. So I know that's not an object because I have a lowercase I. If I typed in integer, I know I have a uppercase I, and if I put my mouse over here, it's going to say unknown data type integer. Did you mean NS integer? Yeah. So what they did is they just took the object versions of the primitives. These are called the primitives or built-in data types. They made object representations of them, and they put NS in front of all of them. So string is an NS string. Integer with a capital I is an NS integer. So if I go over here and I say, well, what about string? I'm going to have the same problem. If I go string, my string, even if I give it the right thing, if I come over here and it's going to put my mouse over here, it's going to tell me, well, do you want to insert this asterisk? And I say, yes, I do. And then it's going to tell me, well, do you want to make this an NS string? And I say, yes, I do. And then I get it corrected. So that's one way of working with the Xcode interface to sort of error check for you if you know what you're doing. It's like the chicken before the egg, though. If you don't know what you're doing, it's hard to make the right decisions when you have all the automation that gets thrown at you in this format. So the point I'm trying to make is that these guys are objects and these guys are not objects. So here, I'll mark this correctly here. This one here is going to be an object. This is object. And this one here is an object. And my ID is an object. But this is generic. So I could actually say my object, which is that object I said, is going to be equal to, and then I can allocate a new object. So let me talk about allocation in a few minutes here. These guys take variable assignments, just like any other variable. So we're familiar with variables, I hope, and primitives. I could just say I is equal to 2, and I can say f is equal to 12.2f and typecast it. And now I have two. I have two variables that I declared. Don't worry about this f, it's a cast. It says give me a float value for that integer I just gave it, because everything by default comes in as an integer. Don't worry about that. We'll get to that later. So it's one of those little particulars about the language. You get the same thing as C, C++. All right, so let's go back to the lecture here. Nil is reserved. Can't use nil. Nil means a null object. It's nil, N-I-L. So ID an object is a generic object. It's because we have dynamic typing. So whatever we do at runtime, when we use the variable or the object, it gets assigned, so it can change. So ID has no information about it. Every object carries an is a relationship or is a instance variable that identifies the object class. So we can say this is a NS integer, this is a string, this is a something else. And objects are dynamically typed at runtime, so whenever it needs to, you run the type, you run the system, you can find exactly what it means, yada yada. You can ask the object what it is. So let's talk about messages. Everything's an object. Objects have three components: identity, state, and behavior. The behaviors are the messages, is what we're having the object do. The identity is to say, NS string, my string. We gave it an identity, called it my string. We have values that we can assign to it. Then we can use my string in other aspects. Normally those are the built-in objects. Usually what we're going to do is add an object to the project. So if we come up over here and go back into Xcode, let's add an object. We're going to add a person into this scenario. So I'm going to make a project that works with people. And then I can inherit a person from, I can make an employee and a person. The same theme I have the tendency to use for all my examples, so no lack of creativity here. So go ahead and click on the directory, or you can actually click up here too. It doesn't really matter. Just click in over here. Go to File, go to New, and this time we're going to create File. So File, New File. Let's create an object. Well, we're going to create an Objective-C class, because I'm going to want to make an instance of an object so I can run a message on an object and stuff like that. So if an Objective-C class is created, I'm going to go ahead and click on Next, and we're going to see this. So somebody actually outside at the barbecue asked me, what are you going to do next weekend? Protocols, categories, inheritance. We'll do inheritance this weekend, but we'll do a lot more inheritance next weekend. And, you know, different types of things, advanced level stuff. So if you're going to miss next weekend, you're going to miss all the fun stuff. So this one's going to be a class, and it's going to come from NS object, so I'm going to type in person. If I type in person, this is the name of my object, that's my identity. My subclass, I'm going to leave it on NS object. So everybody gets inherited from an NS object. And I'm going to go ahead and select next, and I'm going to put it in my starter folder. I'm going to go ahead and select create. So now you see I have a person.h and a person.m, and I've created a new object. And the new object has the same syntax as we saw before. Remember before lunch we looked at a view controller, and we looked at coming from an NS view controller or whatever that was, view controller object. This is person, and person's being inherited from an NS object. It doesn't matter if these two files ended up in supporting files or if it ended up in the starter directory. It ended up in supporting files because I clicked on the main folder when I did this. If I was clicked somewhere else, it would show up where I clicked it, actually. So, I'm sorry?
It's in starters.
Yeah, it says supporting files. I named my folder. I made my project starter. If yours is in starter, it means you probably clicked here. I'm going to make another object actually right now and see if because I think I clicked here. It's going to be in supporting.
It's in the starter one. It's in starter.
You're right, but it's in a supporting. Oh, you're right. You're right. You're right. You're right. You're right. It's alphabeticalized. I'm so used to looking at Eclipse, actually. It's not in the hierarchy. You're right. It is in the main folder. It should be in the main folder. If it's not in the main folder, if it's somewhere else, it doesn't matter as long as it's part of the project is what it's concerned with. But you're right. I'm used to Eclipse where everything is alphabeticalized. And you see it in a hierarchy underneath the different levels. But this isn't Eclipse. Anyway. All right, so going back to person, we have a person at interface with an at end, and then we have a person m. So if I do this again, let's create an employee that's going to come from person, because I'm going to inherit an employee from person. And I know I'm kind of moving ahead a little bit, but I want to build this structure so I can start making objects. If I go File, New, and do that same thing over again and go into File, and then do another one here, Objective-C class, and go Next. Now I'm going to type in employee, because employee is going to be inherited from person. I'm going to go here where it says subclass of, and I'm just going to put a P in here, capital P, and then person gets inserted. So if I use the arrow, I can see that person is now part of my list because it's an object that's inside of my my folder. So if I select person and I click on next, I'm going to stick it in the same directory. Actually, this is where it's going. You're right. Click on create. Now I have employee. So if I look at employee, my implementation just says implementation space employee at implementation end. My .h says at interface employee person, meaning it comes from person object. My person is coming from NS object. So you can sort of see the syntax for inheritance. It uses a colon, very similar to C++ actually. This would be the keyword extend in Java, as I was showing you earlier. So now we have some objects. So we can make instances of the objects back in main, which is going to be our driver program. Because the idea is we're going to make some objects, we're going to add some data to the objects, give the objects some properties and some behaviors, and then run them. So the same thing we did before we can actually do over here. So I'm actually going to build a person for you right now. And then if we work with person, that's fine. And then we can build employee next. So if I go into person, we have some interesting things that happen. If we want to define primitives, like or just variables or data about the person, the syntax is slightly different than C++. We actually put, in C++ you have this opening and closing bracket, and the entire class gets defined inside of the opening and closing bracket. In Objective-C, only the data goes there. The members go outside of it. What's inside of the opening and closing bracket turns into private data. What's outside is public. So it's kind of weird, kind of different. You can change the access to it. If you looked at the other project that we looked at earlier before lunch, you may have noticed that there was an at interface and an at end inside of the .m, right above the implementation. That gives you public data capabilities inside of the implementation, not private. So it kind of messes around the logic a little bit. But we got a person here, so let's do some person variables. I'm going to give the person a name and an age. So I'm going to say NS string, and I have to use a pointer when I do this, and everything's a pointer. So if I say, asterisk for the pointer, and I'm going to call it name. I've defined a variable called NSString, and it's a name. If it's an integer, like an int, and its age, it's not a pointer. All the objects are pointers. All the primitives are just like any other language. So just know that when you're creating an instance of an object, you have to use the pointer symbol. It'll just become natural eventually. Now normally what we would do is we'd have some sets and some gets normally. We do what's called setters and getters. Because this is private and we have public data members that give us set name, set get name, set age, get name in terms of the concept. So let's take a look here at the concept. So those are methods that we're creating, the setters and the getters. And we run the methods after we make an instance of the object. So the messages are in terms of to get an object to do something for you, you're going to ask it, you're going to send it a message telling it to apply the method. So in Objective-C, the expressions are enclosed by square brackets, as we saw earlier today. And this is the receiver, or the object, and this is the message. So if it was person, and I had P1, I'd put P1. If I said, person, my person, if I were doing this in C++, because we haven't seen object creation yet, I'd go new person. Or I'd do the same thing in Java, actually. And then I go new person dot get something, or whatever I called my person, P1 dot get name, set name. In Objective-C, we still use the object reference, and that's the receiver, but we send it the message without using the dot. So there's no dot notation if you're following Objective-C. Instead, you have these little brackets. I have some examples coming up where we're going to say receiver, which is going to be the person, or P1, or whatever it is. And this one over here would say set name, get name. So no dot. So it's the same concept. So the receiver is the object. The message is simply the name of the method that you're going to run. So here's some examples here with my rectangle display, which would be my rectangle dot display. So the method call here has an opening and a closing bracket. Well, we don't have those opening and closing. We don't have parameters in the form of parameter brackets in Objective-C. Instead, we have these colons that are going to separate. Colons are overused in this language, by the way, in my opinion. So colons are everywhere. Colons and brackets are everywhere, and that actually comes from Smalltalk. Because this is what it looks like here. If I were to say set origin, I go colon, and this would be like X and Y. So I got colon X, colon Y. And you're looking at this going, oh, wow. And that would really be X and Y or whatever the origin was, you know, the comma. So you don't have any commas in here. Instead, you got the colons, and the colons are separating everything. And then you get the colon here. Well, you write the method the same way, and then you put the data types in between. So you're still using the data types for the parameters, but you're writing them with colons instead of opening and closing brackets. So when we write our setters and getters, and we'll do it manually so you can see what that looks like, you'll see how the syntax works. So the method set origin dot colon colon has 2 colons, one for each one of the arguments. First argument, colon, first argument, space, colon, second argument. Arguments are inserted after the colons, breaking the name apart. So we have polymorphic and polymorphism in the language. So each object is defined by its own methods, but you may have them for different classes, and you might have the same method name used typically for different meanings in different classes, and 2 different objects can correspond differently to the same message. So we have that message overloading and overwriting, and we have dynamic binding. So it's like C++ without the virtual, with virtual mixed in. So we don't have to, there's no virtual concept. If you're familiar with virtual, you don't like, well, maybe some people like it. That whole concept in C++ is already given for you. It's more Java-like, actually. And we can overload and we can override, and we can change objects through the inheritance. We saw this with person and employee. What we have here is the root object, which is NS object. So the inheritance is accumulative. So a square is a rectangle, it is a shape, it is a graphic, it is an NS object. All the way back up. So that's where the ISO relationship comes from. So instance variables, methods, and method overloading. So the object contains not only the instance variables that were defined for its class, but also the ones that are defined for the superclass. So we have one level and we have another level. So if I have name and age and person, I can go back to employee and just add the employee ID. So I got name, age, and employee ID over there in employee. Same thing you get in C++ and Java. The methods themselves, an object has access not only to its methods, but everything else defined for it as well in the hierarchy. And then we have method overwriting. So we implement a new method with the same name, it replaces the previous one. We don't have to tell the object, we don't have to tell the environment which method we want. It's determined by how we're referencing the object. If we reference the object as an employee, if a method has been overloaded, we'll get the employee version of it. If we reference them as a person, then we get the person implementation of the method, which is actually kind of interesting. It's more clear this way than it is in C or C++, actually. It's a little bit more straightforward. So class objects. We're going to make an instance of a class. So I'm going to give you the syntax, and then we'll make one. We'll make one with our person and our employee. So the compiler creates one class object to contain the information for the class, which we did, and we start an object instance by going, in this case, ID my rectangle. My rectangle is going to be equal to rectangle alloc init. This is where people go, what are you talking about? There's no new and there's no delete. So it's kind of like Java, but Java's got a new but no delete. C++ has a new and a delete. Objective-C takes the new and the delete out of the picture. But you were going to call alloc new. So you could substitute the word new with alloc. And if we were really running this in C++, it would be new rectangle. So now, because we've got this crazy syntax here of the brackets instead of the dots, and we're not using new as an operator in this case, this is like saying rectangle new. But Objective-C doesn't like new. It likes alloc, because it comes from malloc, alloc, dealloc, and all that traditional C behavior that we had. So they kept the naming instead of renaming it new. So to create a new rectangle, we would go rectangle space alloc. And we're doing this in 2 steps. So this is actually 1 step. And then this init is another step. And this is embedded inside of this call. So after we've created the new alloc of rectangle, then we're going to run init. And people are going, what's this init? Well, init is the constructor, but it's not a constructor. It's an initializer. So in C++ and in Java, we have constructors. You know, the default constructor, we have all these other parameter constructors, and we can overload constructors and do all this other stuff. Well, we can do the same thing in Objective-C, but we call them initializers, and they're init. So init is a keyword to run the initializer, and we have to explicitly run the initializer. So not so automatic. So alloc method returns a new instance of that instance, performs an init method to set all of its instance states. So when we define a class, in fact, let's just take the syntax and we'll just apply it right now so we can practice it. Let's see, back to Objective-C. I don't actually have to do anything with person or employee. I can just make some. So in main, in here, I've got my object. So my object can be anything it wants to be. So I could, if I wanted to, create a reference of a person. If I did that, I can go person P1 and put my little asterisk in here. Well, I can do this and let the error checking do it for me. Or actually, I'm going to have another problem. I'm going to have to import person in here. Import person. There we go. Let's start off by importing both person and employee. Let's stick them both in the top of the file. This is very C++ like. Java, you don't have to do this. C++, you got to do this. Objective-C, you got to do this. So I'm going to also import employee in here too. So I got my interface. So I could go person P1, and at this point, if I check there, it's because of that asterisk. It's because the interface type cannot be statically allocated. You have to do it dynamically. You're dynamically allocating it with that pointer. So I'm going to make a person P1, and I'm going to go employee with an asterisk E1. So I got a E1 and a P1. So import both employee and person if you have both of them. If you just did one, just do one. And then these are referred to as a reference to an object. Well, this is a reference to an object too. This is a generic one. So ID is equal to everybody. So in the particular example given to you in the lecture, we didn't type this as a rectangle. But we could have said rectangle my rectangle. And then rectangle equals, and here I'm lazy, I'm going to cut and paste this actually so I don't have to type it, copy it. If I copy it in here, I'm still going to have problems with the typing probably. Let's just see what happens here. It's going to go, well, there's no such thing as a rectangle, so let's change this one to a person. It's going to say, well, there's no rectangle. Oh, my rectangle, yeah, actually, I can call it that. I'm just going to call it P1. So now I have P1 is equal to person alloc init. And then I can go P2, E1. E1 is going to be equal to an employee alloc init. So now I've allocated and I've initialized the new objects that were created there. I can also do this in one step. If I want, I can go person P1 is equal to a person alloc, and it's going to tell me it's unused, so it's still good. Or I can say employee, same thing you can do in C++, E1. Here I will. I want to do a breakpoint, take the breakpoint off. There we go. So I can create the object reference and then create the instance. Or if I wanted to use this ID up here, I could say that my ID, my object, is going to be equal to, and let's create a person with this object, is equal to a person init. Oh, alloc init. Well, let's just go back here and go alloc init. And
has become an
No visible person declares object int. Oh, init, a typo. Hold on one second. There we go. Okay, so sometimes, usually I have to say, well, what is that? What are they trying to tell me? And then I have to find my typos. It's the logic. But yes, I wanted to say init, not int. This is actually a method, and we don't get int. We don't have int defined right now, but we do in NSObject. NSObject has an int. So if I ran NSObject int, which is what I'm doing here, this is really super initializer. So my object here, I could have very well done what I did in the slide and said ID my object. Same thing I did with these guys here, reference and allocation and initialization all in one shot as well if I wanted to. But I don't have to. So that's how we create instances of these objects. And let's move further ahead. So when we define the class, we know that we have a .h and a .m. The .h is the interface that declares methods in terms of method prototypes and variables. We put our variables in there as well. And the .m is just the method bodies that we're actually going to use. So here's an example of our interface. So we declare it with an @interface, and we have an @n. Xcode does it for us automatically. Instance variables go inside of the opening closing bracket, and then we have our method declarations that go at the end. We looked at this live a few minutes ago. These are some instance variables with a float, with a height, the boolean, and an NS color, which is actually a color object. So let's take a look at these minuses and these pluses. So by definition, in Java, the keyword static is used. In C++, we have static. In Java, in Objective-C, we have plus and minus. Minus is method, plus is static. It's class. So as I was saying, Objective-C has got a bunch of symbols in it, all symbol-oriented. So the plus here is a class method. The minus is an instance method. We're going to use a lot of minuses right now because that's all we have an instance. We have an object we're going to create an instance of. Unless we wanted to do a class, and most people who don't know the differences between class and instance, what I'm talking about is an instant method is one that's run by instances of objects that are created of that class, not by the class itself. If we have a class method, we have one value that's shared among all instances. If we have an instance method, we have each instance has its own ability to run the method, and it also has its own ability to see the data and have its own data value. If we had gas level in a car, all the instances of all the cars would have their own different gas levels. If we made it a class level, they'd all have the same value. You change it for one, you change it for all. So between class and instance, at the class level you control all instances all in one shot. The instance level you can control the instances individually. So in Objective-C, that's really what it's used for the most part. It's by a plus and by a minus. Plus alloc is actually a class level. Alloc is a class method. It says allocate. It allocates instances of classes and we run it on the class. So when we said rectangle space alloc, person space alloc, we're using it with a name of a class, not an instance. We initialize that init by using a class level NSObject initializer. It's still running it on a class. So both alloc and init are class level from the inherited NSObject actually. The minus sign says it's from the instance. So void display is our method. As I mentioned before, we could do some easy methods here if we wanted to. Go back to person, open up person.h right now. And what I did is I double clicked on it and it opened up. If you single click, it opens in the window. If you double click, it opens up in its own window. But I didn't want its own window, so anyway. Make some real estate here. Let's write some methods to get or return the value of name and of age. So we know we're going to start out with minus, and we're going to return. Here we're going to return an NS string. So we put the string, NS string is the return type, and it goes inside of these brackets here. And I'm going to call this get name. And then I'm going to make another one underneath it. And I'm going to see what's wrong with you. Here, interface NS string. Can I be returned a value? I forgot to put the, yes, I forgot to put that in there. So it's really returning an asterisk. So you have to put, this is the different, okay, so this is, if you're C++, you're familiar with using the asterisk with instances that you're creating of these objects, these variables. So you have person asterisk P1 is equal to, you're never used to referencing it as a type. So the types in C++ are types, like string, double, floats, person. The object types are still types. In Objective-C, they're reference types. So you have to put the asterisk in there. So even though this was in a string, it wants the asterisk, which is moronic. I don't know why it would do that. So it's just kind of one of those idiosyncrasies things. So I'm also going to make one to return the age, but the age is an int. So I'm going to put here int in here because I'm returning an int. It's my return type, and this one's going to be getAge. And you're going to look at this and go, what about the asterisk? And I'm going to say, well, the asterisk doesn't belong because this is a primitive data type. It's not an object type. We're not returning an object reference. So in order to understand this asterisk, you got to understand pointers. And understand pointers, that's an entire day of lecture right there. I'm going to get into pointers a little bit more, but I don't want to. I'm going to assume that some people have heard of pointers before. If you haven't heard of pointers before, download one of those Objective-C programming books I showed you at the beginning of the class, and find one that you really like and Google or look in there for the word pointer. And you'll figure out what the difference between a reference and a non-reference data type is. Traditionally, in C++, they say that that reference type is a memory address, and you're working with a memory address instead of a value, and they go pass by value, pass by reference. Oh yeah, pointers. Objective-C, it means roughly the same thing, but there's no memory address. It's a reference to an object. So it's slightly different meaning, same concept. But you're never going to use you're never going to do an ampersand. There's no ampersand in Objective-C because you're never going to get the address of something because it really isn't a memory address. It's a reference. So anyway, we have our format for our two methods that we're going to use to get. And so what do we have? We have, well, let's see, we got init and we have an init string. So if I go over to the .m file, well, actually, I'm going to make my life easier. I'm going to copy this here because I hate typing. So I'm in my implementation file, and I'm in between the @implementation and the @end. I'm going to paste in my two method prototypes. But now I'm going to take out the semicolons at the end and actually build the bodies of the messages in here. So this is called an implementation because what you're doing is you're building the bodies of the two methods that you declared. Control reaches the end without, okay, because these aren't void functions. So I'm going to ignore that message for a second because it's not void, it's returning. So I need to put a return value in here. So I'm going to return, and I'm going to return the name. So I'm going to return name from here because this is a get name. And then in here I'm going to return age. So what did I do is I created some getters, what I called getters, get name, get age. And when I did that, I actually made the method and called it get. If we use property and synthesize, it's actually, there's no get. We just get, we get the value that comes out. I'm going to show you the example in a few minutes here. So with our getters, we have a return name. So just like C, C++, if I wrote this here in C, it would look like, here I'll write the one with the integer because it's a little bit easier. If I wrote this thing in C, it would look like integer get age opening. I'm putting in comments here so I can leave it here without the messages. Opening bracket, return age, and then I have the closing bracket. The method would look like that. So it's equivalent to the same. The return type is the same as the type of the method that you're running. So integer is going to return an integer, and a string returns an a string. Slightly different syntax, same meaning, same identical context. All right. So if I go back to person.h here, And hopefully I was in implementation. Yes. So in the person.h, I have name and I have integer defined as data members, and I'm doing this the old way. This is the C++ way of doing things. If I were to do this really truly objective way of doing things, I would use a property instead. So I can go at property. These are properties of the object, attributes of the object. They call them properties. So I'm going to make another property. I'm going to put weight. This is going to be weight. So the at property weight, let's see what's wrong with this. Name requires a specifier or qualifier. Let's just wait with that for a second. If I do a property for it, let's not make a property right now actually, then I'm going to get my setters and my getters, and I'm going to do the same thing as I did with these, which are properties, but I'm using the Objective-C property format. I don't want to mix and match both of them in this here, so I'm going to take this property out for a second, and then I'm going to show you an example that's put together that uses both properties and non-properties. But the property and the synthesize replace this whole process here is what I'm trying to say. When you go property a couple of things, and then you go synthesize a couple of things, it creates your properties and it creates your setters and your getters for both. Okay. So what I wanted to do was show you the instance method, which is what I showed you. So void display. So now we know about the import. We just did that. You have to include or import the .h file to use it. We can also import a class if we want by going at class. If we wanted to take the entire class, we can import. We can refer to other classes inside of our interface in the hierarchy by using an at class. We'll do it later. We're not going to do it this weekend. But you know that you can also import classes as well. So here's some methods, and in terms of the implementation, we have a little method body here. Method body here is going to alloc an init. This can be done anywhere. So this is actually done inside of a method, not inside of the main program, because inside of this method where it says make identical twin, we're going to copy one object to another object and twin it, essentially. And then you notice here, we have the C++ style with the arrow. Same syntax. If you're not familiar with C++, don't worry about it. But know that if you're going to use pointers, you're going to use the same syntax. It's no longer the dot, now it's the arrow instead. But you don't have to worry about that because it's not really a problem. You can also, if you're doing the C++ style, you can also use the at private, at protected, at public. So if you're a C++ programmer, you're familiar with public colon, bunch of stuff, private colon, bunch of stuff. And you've got everything separated out. So unfortunately, I shouldn't say unfortunately, but because then people end up programming in Objective-C like they do C++. You can have a C++ style here. You can actually use the at private, at protected, at public. If you don't put this stuff in, you use the defaults. The data members are private, the member functions are public. So you get the default behavior that works with that. But you can, if you want, use all the at. And instead of it being public colon, it's at public. So syntax is slightly different. So here's a method here, promote to colon new position. And what we've got here is going to be this is the new position. And the new position is the parameter that's coming in. So if I said set name colon name, that would be like putting in set name with integer and a string name with a data type and the name, and then you'd be passing the parameter in, and then using the parameter. In this particular case, we're going to set the job is equal to new position. New position is coming in from the command line, from the call, the method call, I should say. So we know GCC, we know the tools. Actually, I forgot about this, but at the end of lecture number 1, there's a little bit on the GNU step. If you wanted, if you're still exploring your options there, you can look into GNU step in terms of running that. So let's see. I'm going to skip to some examples here. We did this stuff this morning, so I skipped ahead a little bit. We don't have to do the memory stuff anymore, so I'll skip ahead on that one as well. Just trying to see if there's anything else in here I want to cover before I open up an example for you. Well, let's finish this one here with the student. Well, let's just work on the person theme. So we pretty much covered the basics. Hello?
Professor,
Yes?
during they playing basketball, I don't think they should be playing basketball.
They shouldn't be. Let me pause this real quick. All right, so what I just thumbed through, I showed you this morning in different contexts, and it was using the GCC compiler at the command line and, you know, the .h to .m stuff. So what I want to do now is show you what we've taken. We've created some methods that didn't have parameters. Here are a couple that have parameters. And so when we write the method prototype, we're going to take on two parameters. Let's do it for the name, and let's do it for the h, so we can complete this example. And then we can run some instances of these objects which we've already created and run the methods on them. So here we have the syntax. We're not going to use the student, but I just want to show you the syntax. You put a colon in at the end, and then you can put the data. You put the data type in, and then you put what you're going to call it, which is equivalent. Here, actually, let's just do it here. So let's write some more method prototypes here. I'm going to put this underneath here. Actually, I'm going to do this because it really starts out the same. But at the end, let's see, we're going to call this one set name. I'm going to put a colon in here, and I'm going to set it to an NS string. And I'm going to call this one name. So what I just wrote was the setter. So I have an NS string as the data type. So if I were to write this in C or C++, and this is a function, it would look like this. I'll go ahead and put my comments in so I don't get all these messages. It would be string, set name, string, name. The function prototype would look like that, where I've got the data type, the name of the method, and then I got my parameter list in here. But in Objective-C, we don't have the syntax. So we have the colon, the data type, and then the name of the variable that we're going to use. This is the same syntax here, actually. It's the data type plus the name of the method. So then I can write the same thing for the h. So underneath it here, I'll just type this one instead of cutting and pasting. Set h, and we're going to have an integer. And I'm going to call this one the h. So now I have a set name and a set h. So that when I write the method bodies, and I'm now going to switch over to the .m file. And actually, before I do that, I'm just going to copy this one here because I don't want to type. Flip over to person.m, and in person.m, let me get rid of this down here too. I'm going to do the same thing as before, except for now, instead of that colon at the end, I'm going to put the methods in here. And let's see, reach the end. Yes, it's a non-void function. It has to set something, or it's not void. So do I really need to use a string for this, which is actually kind of interesting. I'm not going to return anything. I'm just going to set something. So let's change it. We still have void. So let me go back. I can improve upon this. I'm going to go back to person.h. And this is really void, so I'm going to put the word void in here. I'm not going to return something from here. I'm just going to set something. So I'm going to change my data type to void. Makes a little bit more sense for what I'm doing. Actually, the set age and the get name, let me put some spaces in here, are void. So over here in the M file, I'm going to change the data type here to void. Now I can simply set this. In Java it would be this or self or whatever, or I can just go name to name depending upon what I called it. So if I look back over here on the implementation, if I have the function prototype set like this, when I go ahead to create the and I'm going to take what I'm taking in from the parameter line, I'm going to assign it to what I have on the inside. So I can say that number of undergrads is going to be equal to undergrads, or that was this case. So what are we going to do here? We're going to say in here I have two variables that I've defined, and the variables that I've defined is name and age. So unless I refer to the object itself, I'm going to have the same problem that I have in C or C++, where I'm going to say name is equal to name. And they're going to go, what name are you talking about? My name, your name, this name, self name. So there's a lot of people that would go, oh, this is the P name and P age. And if I did that, then I'd have an even comparison. Or if I come in here and I say, well, all right, I want to go into the .m here and I want to fill in the, oh, I didn't put the age in here. I just have the set name. If I go here, name is equal to name, then I'm going to have this little asterisk that comes up and going to say local definition of name hides the instance variable. And then I can go, well, what do you think? What about this? Is this going to work? And then my message is going to come up. It says use of this is, what is this? Then I can go, well, what about self? And I can play around with it. And I discovered, oh, it's self. It's me. It's myself. Self is this. Self is who I am. If you don't like self, change the name. So if I change the name, if I don't like self, because what you have is the same name. You have a variable that you've defined with inside of the object called name, and I have one that I'm taking on the parameter line, and that one's called name. In Java, they call it this. C++, Objective-C is called self. It's who we are. So if I said self is equal to name, then I got it. And I can do the same thing for the get age here, actually. In fact, let me just do this because I'm lazy. Let's set the age as well. So here I'm going to change this one to void. And I'm going to put in here set age. And I think I had an integer here that came in and it was called age. And then I'm not going to return anything. Instead, I'm going to set the self.age is equal to age. If I don't want to do that, then I do this. I come up here and I say, well, let's just be creative, and I'll just change it I'll just say here, P name and P age. And then come over here to person here and say, okay, P age, P name. And then I can go, well, okay, name is equal to P name. And age is equal to ph. Page. Page is age. All right. Did I lose anybody? Otherwise, if I have two of the same name, I'm going to have a conflict, name conflict. So which one am I talking about? If I'm talking about myself, it's always self. If I'm talking about a parameter, then it's just the parameter. There's no self involved with that. The way to get around that is to use two different names, but that's not always the case because sometimes if you have name redefined, if I put name in employee, self in employee is going to be the employee name, self in person is going to be the person name. It's called information hiding. I can have two names. I can have, when I'm an employee, I have this name, and when I'm a person, I have this name. And I can have two names, and they can both be called name. So, all right, so let's run. Now that we have a person created, let's go back to main. And some people at this point go, well, aren't you going to save anything? It's auto-saved for you. If you want to, you can go up here to File and say Save, and you can save the file, or you can save the project. When you run it, it's saved as well. Like if I, just to go ahead and run it, I'm not going to have anything going on here. I'm going to have a bunch of messages that says this is unused, that's unused, everything's unused. Okay, great, I don't care. At this point, I know it's unused. All right. You can actually set your properties to suppress these messages as well. I like the messages though because it at least tells me why do I have this in here if I haven't used it yet. So let's, we have an employee that we created. We have some setters and we have some getters for it. So let's go ahead and use that. So I'm going to do it down here, and I'm going to use a P1 here. Actually, we don't need it. We can just leave that alone. Actually, take those messages off. I don't like the yellow stuff on there. So now I can say, well, I want to run a set. I created a P1. Let's just talk about P1 for a second. I created a P1. I want to do something with it. So let's run some of those setters and getters because I haven't initialized it. So the name is now null and the age is 0. In fact, we can print out the age and we can see what it is if we wanted to. How do we do that? Well, we know about this Nslog thing, right? So we could go Nslog. we're going to return an NS string from getAge. Are we going to return that? No, we're going to return an integer from that. We'd have to take and convert that to a string because Nslog wants a string. But we could run Nslog. Actually, let's before we do that, let's just set something. So if I do a set, I'm going to set P1. So I have an opening bracket and I put P1 in there. And I'm going to type in set name. And I'm going to put a colon in here. And then I'm going to put a string. And I'm going to put in a string, and this person's going to be called Bob, because there's a Bob in every one of my programs. So Bob's everywhere. So P1, I set the name to Bob. So let's set the age to Bob too. So I'm going to go P1.setAge. And you can kind of see maybe the syntax, where I had to put this at directive to tell the compiler that this was a string. But now if I want to set his age to 21, I just type in the number 21. It's expecting an integer. So I can print that out. I can also do something like this. I can say, well, let's say we have my string up here, right? So let's use my string. So I can say, well, okay, my string is going to be equal to, and let's just run the get name. So p1.getName. And there's my string. And then I can do, let's say for example, nslog, and then put my string in here, my string. And then it looks like I'm doing everything that's associated with, is not string literal, potentially insecure. Yes, it is potentially insecure, but we'll just leave it alone. We will just leave that message alone for a second, because we didn't do a toString cast to it. So to be ultra careful, we could actually convert that to a string, even though it is a string. So long story short, now we're looking at C++ again, or C, or Java, or any other language you worked with, except for understanding that this is the method call now. So instead of going p1.getName, we're doing bracket p1 space getName. So to this object, we're running this method. And then we're still returning it to a string, because this is a string. So just the same way as I think I have an integer I up here, I can do the same thing here. I can say, well, how about I is equal to p1.getAge. And I can go, okay, now I have a, now I have a local variable. So I can do the same thing here. If I wanted to, I could print out my string. I can run an nslog and put this inside of it, get name, and convert it to a name. I can show the text, get the set. So let's say we set the name here, we set the age. Actually, if we run it, it's going to say hello world, and it's going to say, oh, here's Bob. Bob's up here on the top because we printed out the name. So you shouldn't have any syntax errors right now. Everything should be working just fine. So now let's go and review object orientation again. I have this employee that comes. I didn't put anything in employee, but every employee is a person. So I could say, well, your employee here, employee E1, well, I could object cast him to a person if I wanted to. Or I could just use them as an employee. So I'm going to put employee back over here. And if I did that, well, I still have the set name and the get name and everything else. So I'm going to get rid of that message right there. So now I'm going to use E1. And I'm going to say that opening bracket E1, E1 set name, the employee's name is going to be boss. So I got here boss. And then let's set the boss's age to, so E1 set, that's an E1, E1 set age to, let's make the boss 50. There we go. Now I can print out the boss's information, use the boss's information in the object, and do whatever it is I want to it, actually. So that's a couple weeks worth of programming, by the way, in terms of C++. So hopefully this is not your first programming language. If this is your first programming language, this is way too fast for you. So if you're feeling overwhelmed right now, get one of the books in between go through the video after you've read the book, it's going to make more sense to you as well. But, all right, so now we're looking at this and we're going, all right, now what do? We can add some behavior. We can add some behavior to employee, and then we can do the same thing that we did with other behavior that we've done in C++. We can set the name and the age from an employee. We can also ask the object what it is. Are you an employee? Are you a person? Using a, is a relationship kind of call. Same thing we do in Java. And pretty much it's all the same practice as what you do in other object-oriented programming languages, but it's applied to the Objective-C environment. So what I want to do now is show you a more elaborative example. It's not going to be in here. Let's see. Hold on one second. I'm going to stop this one. I'm going to come back to this lecture because there's stuff in here that's useful. But what I'd like to do is go back to those examples for you. The ones I couldn't get at earlier, and see if I can get at them now. And I'm having more luck. Perfect. So what we want to do is we want to download this one. It says Programming Practice 1, and we want to download Programming Practice 2 right now. If you download those two examples, it looks like here it says WSOC Code 2, WSOC 1. That was from the bhacker.com website for those people who missed it. If I unzip the folder, I get Code 1, and then I get Code 2. If I open up Code 1, I have this folder, and it has 3 little subfolders inside of it. What I want you to do right now is, if you haven't run your program, you'll save everything. And then I want you to close out of this one because we're going to bring up another project. So keep this one because we'll go back to it later because we haven't done the employee yet, but I want to show you the implementation before I show you before we do the implementation. So this one's work in progress. It's going to continue with the first lecture. So you can come in and hit save on the project. You can run it. I just like to run it. If I run it, it saves everything, and I know it's the last build. And then I can close it. If I close it, then I can show you how to open up another project, which I actually sort of did earlier. So this one we're going to open is, let's just make sure we got the right one. Let's open up example number 1. So what you're going to see on the outside is a bunch of stuff we've already looked at. So if you're having problems or if you missed this morning, if you click on Getting Started, you'll see the GCC commands to compile from a command line. And you'll see a little bit in terms of the Hello World. So if you missed any part of Hello World from this morning, or if you want to go and you want the files themselves without having to cut and paste and create the files, that's what's on the outer directory. If we hit and double click and go into example number 1, if you double click on the Xcode project for example number 1, you're going to see something very similar to what we just did, but this goes along with the lecture. So this is the student. We did a person and an employee. This one's a student. If I click on here, I see I'm going to have something very similar to what we just did. We have main, which is going to use a student.h. And I see I'm going to create a student. It's going to be an iOS student, and I'm going to go student alloc. And the reason why I'm showing this is because it has a couple more variations in there I didn't show you. So we have, after we've done an alloc, we can do an IO student init at the same time. Because what I'm going to do is talk about initializers right now. When we run an initializer, we're initializing, and it's like running a constructor. We're setting the initial values for the data. And we're initializing the object. So after, it's like declaring a variable and then initializing it. So I say integer I is the declaration. I is equal to 1. That's an initialization. So here we have iOS student alloc, which is like saying, new student, and then initialize the student. So, and then we have the initializer all in one. So it kind of will review the concept of making the new instance of the object. And then this is what we did, set this, set that, and print this. So what is in here is the basic print without any parameters. And this is the same thing we just looked at. And so this one has 2 variables, nothing. Just like same thing with age and name. And then in the implementation, we have the same thing as before. We didn't go the self route. We just did the variables equal to this variable, that variable equal to that variable. So example number 1 is similar to what we just did. Hello world is the first one we did. So it's the first one before I went into the iOS stuff this morning. So I was supposed to show you this stuff earlier. So what we want to see now to continue with the examples is person/initializer. So I'm going to open up person/initializer. And we're going to see the definition of an initializer and what that init means. The alloc, we don't have any choices, we just alloc. Init, we can init with name, init with age if we're talking about person. Initialize with data. It's kind of like making 5 different constructors, one that takes on the name, one takes on the age, one takes on nothing, one takes on the name and the age, one takes on all the different combinations you could possibly come up with. What makes this an initializer by definition is the word init in the name. That's the only thing that makes it an initializer. So we know that these are initializers, and this is kind of like the person we just created, which is why I wanted to close it, because person's already here. We have an integer age and a string name, integer height that was added to it. I didn't put a height in my other one, but it doesn't really matter. But it gives us more to work with here. Now, instead of making setters and getters, I could do the setters and getters, but I'm going to show you one that's going to, I'm not going to do setters and getters again, we just did those. But this is very similar. So now I have init with age, and then I have age. Now, this one didn't put the spaces in here. I like the spaces. You don't have to put the spaces in. Spaces don't really matter. But this one actually has 2. So we have integer height. So we have no default initializer because we have one in object. That's just init. That's what we've been running so far. We went person alloc init. We're running the default. Doesn't take on any parameters. This one now is one that takes on the age. Now we have one that takes on the age and the height. And we say and height, well, what does that mean? Well, we can use these names when we call the initializer. You're going to see that in a few minutes. We can use the names or we could not use the names. So this is a named parameter. It's called nHeight : and it's going to take on the height. Now we have one here that says age, same as before, and height, takes on the height, and name. So we're going to make one with the name. And it's the same syntax as we saw before. You know, you could put a space in here. I like to put the spaces in. I don't know why. I like to see the space. In fact, I'll put a space in up here too. And then people go, doesn't it look like n string times name? And then some people like this. If you're C++, you like that probably. I don't know. Or actually C++ people like that. Long story short, doesn't really matter where you do it. So it doesn't really matter. Just use your own preference with that. If you like that, do that. So anyway, in the implementation, let's see how this differs a little bit, and then we'll see how these objects are actually created. This is new. So what do we got here? We got default initializer. Is this really necessary? No. We just saw it work. That whole program worked without an initializer. But in this particular case, what we ran in the other example is just that, super init. We didn't run self, we just ran super. So super is the object above us. If we are a base object, NS object is above us, super is above us, self is below us. If we're a self, it could be a super to another object. If we build an employee from a person and we're a person, we're self to person, and we're also super to employee, because employee comes up to super. It's like a reverse hierarchy. You have the object on the top, you have employee underneath it, you have you have person underneath it, and then you have employee underneath person. Everybody above employee is super. Everybody at the same level is self. We don't consider anything below. We only go up to NS object, which is the exact opposite. I always tell people, I always imagine it upside down. We grow from object and we build up. They like the other way around. So anyway, long story short, person. So we have an ID. It's a generic object because we don't know what it is. We could put person in here and we'd be returning a person. But why? We're just going to return an object. So that's a reason why ID is used a lot in init. The return type is just an object reference. What are you going to get? Well, self is going to be equal to a super init. Well, super init creates the super object, which is init. So this is what we get when we run init after alloc in main. Well, we're going to expand the technology here, and we're going to say self. If self, so if self is equal to super init, if super init initializes the NS object, returns it back to self. So now self has an NS object. If it worked, then create our object with age is equal to 21, name is equal to blank name, and height is equal to 0, and then return the self. Return us from the initialization. Most people just memorize that. You get into iOS, you never use it. Because you're never going to initialize an object. You're just going to leave it alone. Why are you going to initialize an object? You could. You could initialize it. But for the most part, you're not going to. You're just going to do GUI stuff, or you're going to connect this text box to this object over here, and you're going to use it. There's some more sophisticated stuff you'll end up using later on. More of this is with command line and with Mac applications, actually. It's more traditional style programming. All right, so, yes.
ID is like an object of the root class.
ID is a generic type. Just means a reference to an object.
Okay, like generic object, like the object of the root, the base class.
Yep.
Like Java, the object class.
Yep. It's NS object in Objective-C, but it's identical. We're just returning object. So, which is kind of weird, actually. And in Java, you don't have to say extend object. In Objective-C, you have to say extend, or you don't say extend, you put a colon, NS object. Which is, you don't do that in C++ either. So. All right, so take that with a grain of salt and just imagine you're running super inits in it. If you don't put this in here at all, you're not gonna initialize any data. Initializer kind of looks like a constructor. C++ constructor, Java constructor, Objective-C. They call it an init. You actually have to call init. It doesn't get called automatically, which is kind of ironic. Anyway, so here's one with age. Same thing we did before, setting the name, setting the age. We put a colon in. We put a data type. We could put all of our spaces in here if we'd like. And now we're going to use the same syntax as we did with the method prototypes. We have the age and height, and then we're also going to give it an integer, the height, and a name with an NS string, the name. But what are we going to do in our initializer? Well, it's the same code up here, actually, except we're going to say if self is equal to super init. So if you hadn't noticed, I combined the two statements together. You'll kind of commonly say it like this because there's fewer lines of code. So if we don't get an init, super init fails, we're hosed anyway. How's that going to fail? If we don't have enough memory, it's going to come back and fail on us. Assuming that worked, there's a whole breed of people that would leave this out, actually. And then what you're looking at is a C++ constructor. But it doesn't have the same name as the class name like you do in C++. Instead, you have init in the name. If you have init in the name, it automatically becomes an initializer. What does that mean? Absolutely nothing, because you still got to call it anyway. We're going to see in a few minutes when we call it. Do we really have to do that? No. Is it safer to do that? Yeah, because then at least we know we have an object that was created. We may not necessarily even know that we had the object if we didn't do it. Age is equal to the age, height is equal to the height, name is equal to the name, the height, the name, the age, and then you're going to wonder, what's this and height and name? Well, let's go out. I'm going to skip this for a second. Let's go back out to main. Oops. And in main, you see it right here. Bob gets created, because Bob's in every program. he's Bob, init with age is equal to 55 space and height is equal to 10 and name colon. So isn't it kind of the same as going like this and saying Bob, because he's person Bob. I already called him Bob. Bob, and he's going to be init with it's an age of 55 and then 10 and then at, let's call him Bob. And what error message am I going to get? No visible interface for person declares a selector init with age colon. Well, because we don't have it actually in there, we have the one that has the name variables. Anyway, a long story short, we declared it with the names, so we use the names. We use the names so that we know that this is the height, and this is the name, and this is the age, so that we can figure out, if we put this in here, we've added the name of the parameter right before the colon. So ignore this for a second here, I'll do this. These are two alternate choices. If we didn't put the names in, we would put the numbers in. And we'd sit there and go, what's height? What's 10? What's 55? Not knowing what it is. But because we've declared it this way, we use the and height colon and name colon right before it. So we say, you know, and name. And we have to actually use the names here and height to know that that's what we're talking about. Otherwise, we don't know what order we're putting the parameters in. So this is going to complain again because I have two lines of the same. But long story short, it makes this so that we can figure out which parameter we're adding. Because if we go back to the other one, we only ran one of them here. We can, let's take a look at person again. Person has one that says integer with age and height. So we could say, here, let me make some more people actually. Person Bob. Well, here, let's do it down here. Person P1. I don't have a P1 in here. Is equal to another person. And we'll just do two more here because I can run some more constructors. Okay, so let's make this one P2 so the compiler doesn't complain. Okay, so I made a couple more people. So then I can run here the different combinations. We have one that just does, the age, I think, or something else. I say paste here. Age and the height with no name on it. Takes the name off of there. And we don't want to do Bob in here. Let's just do P1. So we got P1 with integer age is 55 and height's 50. And then I think I had one that just had, let's see, copy. Paste. So let's take this one and make it P2. I think I have one just with the age, actually. Just age. So this is like running the different constructors, but we're running the init, which is actually kind of funny because we're running the init after the init. So we could run the inits by just doing an alloc without an init. So because we're kind of doing a double init here. So in C++, constructors only fire once. In Java, they only fire once. In Objective-C, they fire as many times as you want, with as many initializers as you want. You can just reinitialize the object. In the middle of the object's life, you can just reinitialize it. Reuse it again for something else. Because that's what we did here. We init, and then we inited it again. So we could just do this here, take out the init, and just alloc it. If we don't init, it doesn't get initialized. It just got alloced. So if we try to run it after it got alloced, so we do this here, I'm going to hopefully get an error. If I start to do like, let's just run something like P2. I don't have anything in here, do I? Do I have a show or something, or a print or something in here? Let's see what I got in here. Show age. So if I go P2, show age. That'd be funny because you're like, well, what do you have? You run it, and it worked, except for you have this really weird memory thing that came out of it. Like it worked. So this is one of the downfalls, I say, of Objective-C. In C++, it's all fixed for you. And in Java, it's all fixed for you. No flexibility. So they take away the fixedness of it. They gave you the flexibility and the full control over it. And then they trust that what you're doing is correct. That's not so correct. I've allocated P2, but I never initialized it. So because I haven't initialized it, I'm going to get this here. I'm going to get this. I don't even know what this means. In fact, maybe the message down here will tell me what this means. This message is going to say that age is 21, age is 0, person initializer, terminating app due to uncaught exception, NS invalid argument exception, person with age, height, unrecognized selector, selected, blah, 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 blah. It's got some issues. It's not going to tell me very much. And it's still running. So here's the other problem you run into. You still have this running. It won't stop. Or it's not going to stop. So you actually have to press the little box up here to stop it. And then most people get stuck here and they go, well, where's my program? I can get rid of the bottom screen. Well, you got to bring the back. You can get rid of the back. You just have to come up here and click on here and you'll get the file back. So let's see. If we put this here, take this guy out. I'm trying to think, expression result unused. So this one, we're still going to have problems. We're going to have problems because, well, anyway, I'll have to load this fresh actually at this point. Because I have another thing I can do to it. I can clean it. So here's what happens, and this is very typical actually. You get an error, bombs out on you. You fix it. You say, I thought I fixed it. I thought this thing should just work fine right now. What's wrong with it? It's not working. Oh no. Well, I can start doing this, and this would actually do it because I think I have P1. Where's Bob? Bob's up here. He's the same here. What? I left this P2. Let's put the P1 because I still got the P1 and the P2 working here, which is the problem. So then I can go here and it'll build successful. It worked just fine because I actually caught it all. Sometimes you catch it all, you run it, it doesn't work. Because the temporary memory has pre-compiled it because this object didn't change, so it stayed in object code, but that object over here, only main really changed. And so object P as an example, maybe that was the problem, that one didn't change. So you come up here to product and you go to clean. And you clean the project, takes away all the error messages, makes it so the next time you run it, it recompiles everything from scratch. So now when I run it, I'm not going to see any of the remnants of anything that was there before. I'm going to see I'm just going to see the new stuff from this turnaround. All right, so what I wanted to show you were the initializers. So that's what we looked at. And so what I'm looking at here, actually let me close this window here, is the same stuff we looked at in the last example, but now we have the initializer. So they have this thing called a constructor inside. Oh, I didn't go through the other ones, but it's pretty much the same code. We have this thing called a constructor, but they call it a convenience constructor. So we can create a constructor, stick it inside of the class along with the initializer, and call it something like construct me or something. And we still call it, but when we call it the constructor, the reason why they call it a convenience one, because it's going to alloc and init. So we don't have to run alloc and init inside a main. We put it inside the constructor and we use it to construct the object. You know, so it's like different meaning of the word constructor. Has the same meaning as it might have in like C++ or Java, but those are built-in constructors. These are fake ones. They're called convenience constructors, meant to automate the convenience of creating the object. All right, so if I take a look here at some of the other ones here, and let me just finish this out and we'll take a break. We saw the initializer for the default. It's default because it doesn't take on any parameters, it's optional. But here we're going to set the name and the age. And then we have this constructor here that sets init with age and height and everything else associated with it. Then we have init with age, the age and the height. It's just doing the same thing. It's returning self init with age. So these initializers are running the other initializers. So instead of reinventing the wheel and copying the same code and using it 5 times, we're writing it once, which is we wrote it here. And then, or we write it here, wherever we write it, and we call it over and over again. So this one here, self, is calling init with age and height, and name. And names are being set to something, because this one's just setting the height and the age. It's not setting the name. We just hard set the name. But we called the other initializer. So you see this a lot with these initializers. You see this in other languages as well. You see it in C++ and Java. It's not really a strong practice in those languages, but it's a stronger practice here because there's that tedious implementation that you have to do of these initializers where you don't get the auto behavior elsewhere. So you figure you might as well just have one initializer call the other ones. And it basically cuts down your work a little bit. The show age method simply does an Nslog and it shows the age, returns the age. And you can kind of see that this is very similar to the printf that we get in C. There's no C in and C out unless we include iostream.h, and then we're talking about C++ merged in with Objective-C. Because iostream.h is simply C++. But the Nslog is the console, that's that little window, or the DOS prompt. And so the age, with this key here, the %d, %i, %s, prints out objects, prints out floats, integers, doubles. It's called the text formatting. So. All right, and that's a conclusion of the person initializer, which is part of code number 1. So code number 1, the first example set that you downloaded, has everything that we talked about so far in the class. So you don't have a computer with you, you go home and you figure, oh, what was she doing? I'll take a look at those examples. Where are those examples? They're here. And that one is, just in case you lost it, it's Programming Practice 1. So let's take a mini break and we'll start in with Programming Practice 2 and move on. So let me stop this video.